When your software product gets so many new users that it can no longer run on a single server, it is time to scale. Sharding is the easiest way to do so. Let's explore the basic principles behind the sharding architecture, its core building blocks, and the typical challenges. To understand the core idea behind sharding, imagine that we are running a local grocery store that serves a small community. We have a single cashier in the store that can easily handle all the in-store purchases. Now, imagine that a huge apartment complex had opened in the neighborhood, and the number of customers increased tenfold or hundredfold. This is a problem for our small store, as a single cashier can no longer serve all customers. Customers must wait in long lines, and they may get frustrated by the long waits, leave the store behind, and spend their money somewhere else. This is bad for our business, so how do we avoid this? The solution to our poor grocery store business would be to increase the number of cashiers. This would allow the store to serve multiple clients in parallel and reduce the wait times. In addition to the new cashiers, we also need to establish some basic rules around how customers pick their cashier. We really need to avoid situations when all customers go to a single line and overload a single cashier while other cashiers are idling. This is essentially how sharding works. Here are the steps to scale a system where a single processing server is overloaded. First, add more servers which are identical to the one that you already have. We call these servers shards. Second, add a special machine called router to your architecture. The only job of that router machine is to take requests and send them to the right shard server. With sharding architecture, generally only one shard serves the requests from a particular user. That is, when one of our users, Bob, creates his account with us and starts interacting with the system, all his data is stored at and processed by a single server. His request should never go to any other servers in the system. The logic to assign users to shards is what's called Sharding Schema. The simplest Sharding Schema is to consistently split all users evenly between the shards. This can be done by using the formula hash of user ID mod number of shards. For example, if we have 3 shards, then requests from users with IDs such that the hash of user ID mod 3 is equal to 0 go to shard number 0, equal to 1 go to shard number 1, and equal to 2 go to shard number 2. Of course, the sharding schema rarely stays the same as your system evolves. Sharding schema very often needs to be changed when new shards are added to the system to handle even more additional load. When this happens, it's recommended to have new shards to serve only the users that's registered after these new shards got added, such that you don't need to move the existing user data across the shards. The main advantage of sharding architecture is that each shard server doesn't really need to communicate to other shard servers. Each shard has everything to process requests from the users that are assigned to that particular shard. So the logic within each shard doesn't need to care about scaling at all. Each individual shard works exactly the same as the original server before scaling. The only difference is that each shard now processes only a fraction of the users instead of processing all of them. This reduces the complexity of the shard's logic and makes individual machines to operate just like there are no scaling issues at all. The other advantage of the sharding architecture is that all scaling logic is dedicated to a single router component. If the sharding scheme needs to be changed, there is only one place that needs to be modified. This localization of scaling logic helps to reduce the overall complexity of the system. The main disadvantage of sharding architecture is lack of auto-scaling for uneven load. If some users put more load on your system than the others, some shards may get overloaded while others are idling. This is called the hot shard problem, and it's generally needed to be detected and resolved manually. A common solution for the hot shard is to modify the routing schema such that all users that cause heavy load are not processed by the same single shard and instead are distributed evenly across all shards. The sharding architecture unfortunately is not applicable to all scaling problems. It works the best when there are a lot of users, but the load from each user is relatively small. It does not work well for scenarios when the load from a single user cannot be handled by one single machine. For those type of scenarios, other architectures, such as MapReduce, would be a better fit. If you want to learn more about other scaling architectures, such as message queues, Or if you're interested in engineering career topics, check out other videos on this channel. Give us a like and subscribe, and we'll see you in the next video.